All right, hello again, pre-capitalist people. So we're going to continue with some trigonometry today and talking about what I call trigonometry in four quadrants. It still uses SOHCAHTOA, which we've been doing for a little while now. But basically what happens, there's two different kinds of questions. You can either see a question where we give you information about two kind of known trig functions, and then we have to find another trig function based on that information. And then there's another kind of question where we're giving you a point on the terminal side of the angle of the theta, and then we can find values of trig functions that way. So I'm going to start on this side. And in class, we talked a little bit about the other three trig functions, cosecant, secant, and cotangent. I'm not going to go through kind of that detail in this video, but just know that if you know sine and cosine, you know everything else, right? Because we know we know tangent is equal to sine over cosine. And then the bottom three ones are just reciprocals of the known ones. So cosecant, it relates to sine, secant is the reciprocal of cosine, and of course cotangent is just the reciprocal of tangent, okay? So the other thing we need to kind of make sure that we're comfortable with before we start on the examples is knowing your quadrants and knowing which trig functions are positive and which ones are negative in which quadrant. So I have a kind of a little cheat sheet here for you here. Of course, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So make sure that you understand and know these. And again, they're just based on the x and y values, right? Because we know sine on the unit circle is the y value, so that's why sine and cosecant are positive in quadrant 2. Everything else is negative. We know that x and y are both negative in quadrant 3, which is why the cosine and sines, cosecant, secant are negative. And then the tangent, cotangent, though, are positive because you do negative divided by negative and get a positive. Same thing the other quadrants, right? Quadrant 1, they're all positive. Quadrant 4, the x's are positive, so the cosine, secant positive. Everything else is negative. And then here are the steps. I'm not going to read these out before I start doing the examples, but we're going to go through these steps one by one. So step 1, here's a question. Cosine theta is 3 over 5 and tangent theta is positive. We got to figure out what quadrant it's in first. So think to yourself, okay, I know cosine is positive, so that narrows it down right off the bat to either quadrant 1 or 4. And then I keep on reading, tangent's also positive, so it has to be in quadrant 1. Okay? Once you know it's in quadrant 1, then we're going to draw a triangle in that quadrant. So the only rules on this are we have to draw the angle from the origin, and then we're going to complete the triangle by going back to the x-axis, whatever quadrant it's in. So my theta is going to be there along the x-axis. And then we're going to use SOHCAHTOA to label our sides. So in this case, cosine we know is adjacent over hypotenuse. So that means my horizontal distance is 3, that's the adjacent. Hypotenuse is here. And you probably recognize this is a 3, 4, 5 triangle. But in case you don't, we can always do the Pythagorean theorem. So we got that. So b squared is equal to 16. And that's a clean number. So we know b is equal to 4. Once we have the whole triangle labeled, it's all done but the shouting. Because at this point, we can now answer the Durham question. So we're asked for what sine theta is. So we know that's opposite over hypotenuse, so that's 4 over 5. And we can answer anything else too. Like say, for instance, it was asking for cotangent theta. Well, cotangent is adjacent over opposite, so that would be 3 over 4. Okay, and that's really all there is to it. So determine the quadrant, draw the triangle, label, Pythagorean theorem to find the missing side if you need to, and then answer the question. So I've got 2 more examples here. I'm going to try to leave this up here for you here. If you need to take a picture, I'll tell you what, I'll kind of put it right there for a second. If you need to take a picture, make sure you have all the ratios and the quadrants You can pause the video for just 1 second. Okay, so next question. Tangent is negative, and the sine is also negative. So think about your quadrants. In which quadrant is tangent negative and sine negative? Well, that's going to happen here in quadrant 4. So again, just draw a triangle in quadrant 4 somewhere, always coming from the origin and always returning to the x-axis. So there's my theta. Label opposite adjacent. So opposite is 5, adjacent is 13. Now, using common sense here too, because we know in quadrant 4 the y is negative, so that 5, that's where the negative comes from because it's going down. Pythagorean theorem, in this case we're finding the hypotenuse. So we've got 13 squared plus a negative 5 squared is equal to c squared. That's 169/25. And that's going to be 194. And for me personally, you can check with, you may have a different teacher if you're watching this video, but for me personally, I'm fine with leaving it as root 194. I definitely don't want a decimal, and I just don't really care about simplifying the radical in this case because it's all mathematically equivalent. But your teacher may want you to simplify that if possible. But again, I'm going to just leave it as root 194. And now that everything's labeled, now we can answer the question. So again, cosine theta, adjacent over hypotenuse, 13 over root 194. And whatever else you want to do, like let's say, I don't know, how about cosecant? If we did cosecant theta, that's hypotenuse over opposite. So that would be 194 over negative 5. Whatever else you want to do. So I'm going to ask you right now to pause the video, see if you can do that third example on your own. Again, determine the quadrant, draw the triangle, label, and then answer. Okay, so for the quadrant, we know cosecant, relates to sine, is positive, secant is negative. So if cosecant is positive, it's either in 1 or 2. Secant is negative, that puts us in quadrant 2. Oops, draw a little more room here. So quadrant 2, draw the triangle. There's my theta. Cosecant, that's hypotenuse over the opposite. So that's going to be 24, and that's going to be 7. Pythagorean theorem. That's 49, and that's 576. Subtract the 49, 527. And again, I'm okay with leaving it as root 527. And again, common sense comes in, so we know this is the x value. So we know, since it's going to the left, that is going to be our negative value. Again, just knowing that from what you've been doing since middle school with quadrants. Everything's labeled. I can answer the question. Tan theta is now equal to opposite over adjacent, 7 over negative root 527. And if I want to find, I don't know, how about cosine theta? If I want to find cos theta, how about negative root 527 over 24? Okay, so that's the first kind of sort of problem you can see on these 4 quadrant questions. The next kind of question, now the next set are actually easier, to be honest with you. The next set is when we're going to be given a point on the terminal side of the angle. These are actually easier because given the point, you know right off the bat what quadrant you're in, right? So again, it's similar kind of steps. So we know if it's negative 4, 3, we know that's going to be in quadrant 2. So again, just sketch the triangle in quadrant 2. Same way you did it before. And again, if we know this is -4, 3, then that tells us the -4 is the x and the 3 is the y. So that's our two sides of the triangle. And again, we can use the Pythagorean theorem to find out what the hypotenuse is. In this case, it's going to be 5 because again, it's a 3, 4, 5 triangle. And then once you have everything labeled, we can answer the question. So sine theta, opposite over hypotenuse, 3/5. Secant theta, hypotenuse over adjacent, that's 5/-4. And that's it. And again, you may have a weird square root as that, but it works the exact same way. So again, quadrant first, 2, 9, that's in quadrant 1. So that's the point 2, 9. So again, that's my x, that's my 9. I didn't draw it very good, but who cares? Pythagorean theorem, I'll use Pythagorean theorem this time because it's not a clean one. So 2 squared plus 9 squared equals c squared. On these, you'll always be, if you're given the point, you'll always be finding c because that's always going to be what's missing. So you got 4 plus 81. So 85 is c squared. So c is equal to √85. And again, label that on there so it's on the triangle. And then answer the question. Tan theta, opposite over adjacent, 9/2. And sine theta, opposite over hypotenuse, 9/√85. And you can do the other trig functions if you needed to, whatever one you wanted to do. So again, one last time, go ahead and pause the video, see if you can do number 6 on your own. And then we'll go through that answer. So here, obviously, they're both negative, so that's going to be in quadrant 3. So -13, -5 is going to be down here somewhere. -13 is the x, -5 is the y. Pythagorean theorem to find my missing side. Again, it's hypotenuse. So it's 169 and 25. And that is 194. I think I did on the first page too, didn't I? I like using the same numbers. So C is √194. And now we can answer the question. So we want, we want cosine, which is adjacent over hypotenuse, -13 over √194. And tangent theta. Now watch your signs on this one. Tangent, again, opposite over adjacent, -5 over -13. But two negatives make a positive. So tangent is just going to be +5/13. So that is how you do 4 quadrant trigonometry problems, 2 different kinds. If you have questions, as always, you can send me an email, drop me a message, talk to your teacher. Until next time, stay safe.